Hi there guys, today we're going to be talking about or constructing our isometric circles, and we're going to be using those isometric circles to get those isometric cylinders. Right, in this case over here we're going to start with a basic cube, and we're going to construct our isometric circles. So I'm going to use my isometric circle construction method, going from my obtuse angle to the opposite center. Yet again, obtuse angle to opposite center, obtuse angle to opposite center, and obtuse angle to opposite center. And I'd like to go and draw my circle, so I'm going to go to the intersecting point, to the parameter, and scribing my arc. Right, just pay attention that I've used the correct intersection point, and I'm scribing my arc from this point over here to this point over here. This line over here is indicating where I start, and this line will indicate where I stop. Or I could do it the other way around. I could have this line indicate where I start, and this line here will indicate where I finish. Right, let's do the other side. Please, you will be doing this with your compass. So you'll simply be putting your compass point on that point there and opening it up to the parameter. Note that I'm doing this all in construction to start off with. There will be a reason for this. Right. Now that I have actually found my isometric circle, I've got to remember that this isometric circle has its own center lines. It's standing on its own, therefore it will have its own set of center lines. I'm going to include those. Remember that this line over here that I have over here highlighted has its own center. SolidWorks has kindly highlighted that for me with that yellow dot. So I go ahead from that yellow dot, I can line it up and simply draw lines straight down. You'll have a nice vertical line, so you'll pull your T-square up with a nice 90-degree set square, and you will draw your own vertical line. Please remember, when you are drawing center lines, your center line must break through the actual circle. Alright, please don't have your center line go all the way down to exactly the circle's edge. It must break through, it must go beyond the outside of the circle, or the inside of the circle to the outside. Right, we have it here again. I want to have this at an angle of 30 degrees. That's going to be an isometric line. Right, now I'm simply going to extend it on this end over here. Alright, I don't like it being extended that far, so I'm just going to make it a little bit shorter with my trimming tool. Trim. There we go. Alright, so remember please that your center line will be in a final line. It will be nice and dark. Okay, so we're looking at cylinders here, so let's draw our isometric circle at the back as well. Since this is a cube, I know that my construction line is going to go from here to the center to give me a 30-degree line, and from the center up. Now I just would like to double check this accuracy of this line. It looks fine. There we go. I'm happy with that. Just for a moment, I'm going to be deleting this line here so you can see that this is the actual platform at the back. So I'm going to go ahead and construct my isometric circle at the back, from obtuse to opposite center. Thank you to SolidWorks. I can see which one it is. Please make sure that you measure this line and then accurately find the center of this line over here. Obtuse to opposite center. And I'll do the same. Obtuse to opposite center. Obtuse to opposite center. Right, I'm going to be opening up my compass from the intersecting point all the way out to the parameter, I'm going to be scribing my arc from and to, like we explained in the front here. And I'll do the same with the opposite side. Let's scribe my arc from and to, like I did in the front over here. And I'll use my compass to join these two existing points over here. Yet again, I'm not too happy with the actual accuracy. I'm going to do this again with my compass. I'll zoom in on the intersecting point. That looks a little bit better. I'll zoom in on this intersecting point here. That looks a little bit better. Right, from my obtuse angle all the way to join this end to this side over here. That looks good. And my compass is going to stretch from this obtuse angle to join this point over here to that point over there. Lovely. Right, now that I have an isometric circle, at the back it also has its own center lines. Remember, the one in the front over here has its own set of center lines because it's standing on its own. And the circle at the back also has its own center lines. So let's include those center lines. We'll include them as final lines. We'll line it up with SolidWorks giving me that helping hand. And yet again, at 30 degrees, we want to go from the center point beyond the circle. And I'm going to simply just extend this one over here. That's perfectly fine for the drawing that we are doing. Right, so if we are going to be using this circle in the back and the circle in the front to make our cylinders, we simply know that we're going to be joining the circle in the front with the one at the back with two lines. And I've got one line that I'm heavily reliant on, and that will be the one going from acute angle right through the center, through each one of these intersecting points to the other acute angle. I'm going to do the same with the front. From here, all the way through the center, my intersecting points to the other acute angle. Right, so let's zoom in on that. Right, we know that where this arc meets up with this long line that I've drawn over here, remember this is the longest line that I can draw. It is longer than the line I'm going to draw from obtuse to obtuse. So make sure that you're drawing it from acute to acute. So this point over here that SolidWorks is highlighting as a yellow dot, that point over there, let's quickly see over here, there, that will in fact be the center of the arc, and it will be the actual line or the point that I'm going to be constructing a line from and to. Can you see the cylinder starts taking shape? From and to. Two simple lines has given me a complete cylinder. Right, now the trick is, because I've made it a cylinder, I've now also got to include one more center line. These two circles don't stand by themselves anymore. Now they become one shape, and this shape is called a cylinder by terms of these two lines joining these two circles. So I'm simply going to take a center line, and to indicate that I have one shape here and the center of the actual one object, I'm going to also draw this at an angle of 30 degrees from the center of this circle over here right through the center of this circle. I'm going to extend it slightly like so, and I'm also just going to give a little line there so that I can extend using the extended entities tool to that line there. Great. Remember, that's also going to be in a final line. Okay, so if you simply want to draw a cylinder, that's how you'd go ahead and draw a cylinder. Now, The reason why I only did this in construction is because I actually want to draw another smaller cylinder extending or extruding from the front surface cylinder. Okay, so let's see. I'm going to just take away the confusion a little bit. Not that you can on your drawing, but you will have a whole lot of construction lines. I'm going to take away my construction lines just to take away the confusion and for explanation purposes. Okay, I would like to add an extruded cylindrical shape coming out from this front surface, and that diameter of that circle that's going to be extruded from this front surface is going to be slightly smaller. Therefore, I will obviously have to draw a smaller isometric square in which this isometric circle is going to fit. Alright, so if I look at the diameter or the dimensions, on that, I've made it 60 millimeters. I'm going to make another one inside of it 40. So how am I going to go about this? The lucky thing is we know where the center of this object is, and the center of the cylinder that's going to be extruded from this is going to share this center line. So I already know that if I have a diameter of 40 to work with, I also have a radius of 20 millimeters. So the radius will obviously take me from the center out, and from the center out, this way over here and back down, to get the square shape, the isometric square, which means I'm going to have to draw or use 30-degree lines. So let's get to it. I need to measure from the center 20 millimeters out. You will simply just take a ruler and go put it on the center and measure 20 millimeters. In my case, I just have to draw a line over here at first and make sure that that line from that point to that point there is in fact 20 millimeters. Oops. Right, I've made it 20. Okay, so that'll be the first point over there that I'll be working with. Let's go draw another line over here. I'm going to just go ahead and draw some lines from the center out, and then I'll measure them from the center out. Okay, let's go and measure each point from the center to there. I will have to have 20. From the center to there, I will have to have 20. And obviously from the center down. Up. It looks like I've got the line there. Okay. Alright, so that now that I know that those are 20 millimeters apart, I actually accurately have the points at which I'm going to start drawing my isometric lines. Okay, so let's do that. I'm going to go at an angle of 30 degrees and take note that I'm going to keep them at in construction, and I want to make that line 20 millimeters. So I'm going to go from this side out 20 millimeters. SolidWorks has kindly lined it up for me over there, if you can see, like that. Okay, I don't want to draw another line there, thank you. Right, and I can simply go ahead and go and copy that line. You will just go 20 millimeters out that way. From this point here, you'll go 20 millimeters. Right. I'm going to copy again, and you're going to do the same. You're going to go 20 millimeters out from there and there, and you're going to draw or construct as such from the end of those points or lines straight down to find that point there. Let's make sure we do in fact have the accuracy correct. There we go. To that point over there. Okay. Alright, so we now have found the isometric square within yet another isometric square. I'm going to highlight them for you quickly. Over there. This was the original isometric square I had to draw to get the big circle. And now I'm going to draw I have drawn the isometric square in which the smaller circle is going to fit. There it is over there. Right, they're the two isometric squares. Okay, so if I've got the inside isometric square in which an isometric circle is going to fit, I might as well go ahead and have an offset to this inside surface of the isometric square. Remember when we spoke about offset surfaces earlier in one of my other videos? We simply took that surface and projected it out at 30 degrees in the same direction as it is facing. Right, so I'm going to do exactly that. I want to make that cylinder about 70. Now let's make that 60 millimeters long. There we go. I'm going to do the same. In fact, I'm going to copy, which makes, for the purpose of this video, makes it a little bit shorter, but you will simply just go ahead and draw 30-degree lines, or construct 30-degree lines at 30 degrees from each one of these corners. Very important. There we go. I'm going to keep it like that. Okay, and now I need to simply join this point to that point, this one to this one further up, this point to that point over there. Okay, for confusion's sake, I'm just going to take this one out for the moment so that you can see that this surface over here has an offset, and there it is over there. I'd like to also extend my center line going out so that I can see I'm going to use the same or a common center, but we'll get to that in a moment. I'm going to use my construction line to go ahead and construct an isometric circle. So I'm going to go from obtuse angle to opposite side, obtuse angle to opposite side, from the opposite obtuse angle to opposite side, obtuse angle to opposite side. Please take note that these two lines are in fact horizontal. So if you don't end up with a horizontal line, you must be doing something wrong. Okay. And I'm going to go ahead and describe my arc from the intersecting point to the parameter. And there we go. From the intersecting point to the parameter. My compass point and the obtuse angle joining this point to that point, and the compass point and the opposite obtuse angle joining this point over here to that point over there. Marvelous. Okay, so I've actually gone ahead and created another isometric circle, which is also standing on its own. Remember, like we did it in these isometric circles, we're going to do the same here. So I'm going to give it a center line from center past the center. It's over there. And we're going to do the same vertically from here through there. That one doesn't look too accurate. Let me find some accurate points. From there through there. That looks better. And I know that these two lines also are going to be final lines. Brilliant. I'll extend them as well. Okay, so now that I have center lines that are breaking the circle, you can see that this the circle, this isometric circle, is going to be smaller than the one at the back there. But I have this square to put an isometric circle into, so I'm going to go ahead and just quickly delete these lines so I can take away the confusion as to where I should be. Okay. Now I want to construct an isometric circle inside here. Now the pleasures are going to be, I already have my center point, because I have a center line going through this side over here vertically and this side over here at a 30-degree angle. Alright, so there's my center there, there's one there, and there's one there. So if I'm going from my obtuse angle, I already know where my opposite center is. I don't have to even go and measure it. I've done it before. So I go ahead, I construct that line, and I continue from my obtuse angle to opposite center, obtuse angle to opposite center, and obtuse angle to opposite center. Okay, and then I can naturally go ahead and scribe my arcs and find the isometric circle at the back. Right, what I actually want to show you guys now too is there's another way of finding the same circle projected to the back. So let's do it without these construction lines. Now ultimately it would be quite accurate if you used each isometric circle with its own constructions completely, but for time's sake in an exam or so, you might have to rely on skills, a little bit of extra knowledge. And I'm going to simply take my line at a 30-degree angle. Right, so now I made that 60. I think it might be 330. Let's just test it. Right, and I'm going to go back. Now, take note, it's gone straight back from this center point over here. Let's make sure, no, not that center point. From this center point over here to that center point over there. That gives me a nice 30-degree line over there. Now, I know that I need to draw from that point over there to that point over there. So if I've projected one point back onto this isometric square, I could obviously project a lot more points back onto this isometric square. Now you'll have to be very accurate. Right, so let me go ahead. I know that my compass points are the ones that I need. There's one over here. And I'm going to project that compass point back onto this isometric square, or this isometric square surface. And that will naturally be the compass point I need to use to scribe my arc. So I go ahead, I select my line tool, and I want to have it at 30 degrees. And also 60 millimeters, because that was the actual offset. I'm going to select my intersecting point, and I'm going to draw my line. I'm going to go to yet another intersecting point over here, select it, and at the end of that line that is 60 millimeters long over there will be where I put my compass point, because that is exactly where I put my compass point over there. Okay, then I obviously know as well that I'm going to be using my obtuse angles to join the opposite center to the opposite center, like I did with this arc over here. So let's see if our theory proves right. We're going to go ahead, open up our compass to the end of this line, open up to the parameter, and I'm going to scribe my arc perfectly over there. I'm going to do the same with this one over here. Open up my arc, scribe my arc to there. I'm going to go to the obtuse angle to join this opposite side to this side, which is also an opposite side. And I'm going to use this obtuse angle to join this point over here to this point over here. Alright, so I've saved myself a bit of time by not constructing an isometric circle all over again. But if you are worried about being accurate, I would, if I were you, go ahead and construct the isometric circle all over again using these lines from obtuse to opposite centers. Okay. Now that I've found the inside circle, you might note that all the circles that I'm using are in construction still. Yet, this circle over here also stands on its own and also has its own center lines already drawn. Perfect. So I don't have to go and put in extra center lines over these. They're already there. This one already has its own center lines because it's a circle or an isometric circle standing on its own. Let's make the smaller circles a smaller diameter cylinder. I'm going to go ahead, open up my line tool, and I want to go from a tangent point to a tangent point. I obviously want to go and draw a line from right through to from acute to acute. I'm going to do the same to the destination surface from acute to acute, and then therefore I'm going to simply draw a line from here across to that side over there. Brilliant. And I'm also going to do the same at the bottom. Two lines. Now the question begs, which are the lines or arcs that are going to be seen and which are not going to be seen? Quickly, I know that this line over here and this line over here, along with this surface or this line over here, will be seen. So I'm going to convert those to final lines. Let's see how that pans out perfectly. I know that this line over here and this line over here, along with these two lines, are going to be seen, forcing my cylindrical shapes. I'm also going to be seeing this arc over here. Let's try and change that. Okay. And I'm going to be seeing the entire surface of this isometric circle. So let's change each one of those lines to a final line. This is looking good. One thing that I have not done is I haven't extended this center. Remember, we said we are sharing centers. So there's a common center between the bigger cylinder and the smaller cylinder. I'm going to just quickly extend this line over here. There we go. Just so that you realize that it has got the same center right throughout the entire object, because remember, this entire object is now one object, even though it has two cylinders attached to each other. And for this video's sake, I'm just going to trim this arc over here and this one here, because remember, we're not going to see beyond this line over here and this line over here. So I know that I'm going to be able to go and make these final lines. There they are. And the same with the cylinder over here. In fact, I'm going to see beyond this point over here because I've got a smaller cylinder over here. So I'm going to be seeing this arc, the entire arc, and that entire arc as well. And final line. Brilliant. But then I see that I've got a portion of this arc over here that is actually sticking out. Okay, from this point here to this line over here. The rest of it I won't be able to see, so I'm going to trim all that off. There we go. And I've got the remainder of that arc over there. Let's change that to a final line. There we go. Okay, as you can see, it goes all the way. Now remember, you can't simply take this same arc and just simply scribe all the way to the surface over here. You actually have to use this this isometric arc over here in that portion over there. Okay, don't get that wrong. Okay, I'm going to trim this area over here so that I can get in and highlight this one over here. That's another portion that will be in final line. And also, I'm looking at this isometric circle over here. Which portion will I see and which will I not see? I'm going to go ahead and trim that side there and that side there. And I'm going to convert this line or this arc and that arc to a final line as well. That's looking good, guys. Alright, we're getting there. In fact, I think we are almost done. Yes, we are done. I'm just double checking all the lines are on final that need to be in final. Great. Okay, so guys, there we have a smaller cylinder attached to a bigger cylinder, and they are sharing the same center line, as you can see over there. Please remember that each isometric circle has its own set of center lines, one vertical and one at 30 degrees, right? Just as this one over here has its own set of center lines, vertical and at 30 degrees, the one in the front also has its own set of center lines, vertical and at 30 degrees. When you are joining circles to each other, you will need to include this center isometric center line, or the center line at 30 degrees. Right, guys, we have offset surfaces that we've covered. We've covered the construction of an isometric circle. We have now attached isometric circle to another isometric circle, or a cylinder to another cylinder. And I hope this has really helped you. Thank you for tuning in, and we'll stay tuned for more videos.